Okay, all right. Glad you're here. And we made it to the end of the week just fine. Nothing really bad happened, and even by the end of the first week, we were able to get everything going pretty smoothly. For the announcements today, I got, let's see where, shoot. Still have the usual announcements. I've been getting some questions now that it's the end of the week. I've been getting more packets turned in to me. So one of the questions I've been getting is, how do we turn in the packets? There are two options that you can do. The first option is to take a picture and send it to me, send it to my email. I think that's the best way that most of the teachers have decided that we're going to do that. Just turn in assignments and take pictures of them and turn them into the email. That way, because I think there's still a bit of fear of the virus going around. So, and it lives on surfaces like cardboard or paper for quite a while. So if you turn in paper packets, which I know that is probably the only option for some people, then I'll probably sit on it for a day, maybe 2 days. I don't know what the recommended time for that's going to be, but it probably will take a little bit of time. Maybe I'll save it for the weekends or something. In other news, I finally got my YouTube channel working. So yesterday or so, I sent out the links for 2 video sharing platforms. The first one is YouTube. So YouTube's pretty easy. Everybody knows how to use YouTube. You know, sharing and subscribing is pretty easy, and pretty much all the videos are going to be there. So all week, pretty much every video I have is going to be posted there. Yeah, it's YouTube. Nothing special about that. The next one I have is Wistia, which is what I used when I was taking classes. And it's also a video sharing platform as well, but I think this one has an extra benefit that you can download it. So if you have spotty internet, you can take it, take your phone somewhere to somewhere there's Wi-Fi, you know, McDonald's, a friend's house, something like that, and you'll be able to download the videos and watch them on your own time and be able to work on the problems, you know, in the comfort of your own home. There is one downside to Wistia though, and that is I'm using a free account, so I'm only able to put 3 videos on at a time. So I'm gonna have to find a way, well, that's where it comes in handy to have the videos of a full lesson. And something I'm probably gonna end up sending out later, but I wanna get some things to make email communications more efficient. So when sending me an email, make sure you include your name, all right? That sounds pretty obvious, but sometimes if I get something, a message, an email from somebody, and it's like, you know, teddybear2004 at gmail.com, then I'm like, who is this person? And I usually have to go through my record and look for that email, or if I don't have it, then I have no clue who it is. But even then, it takes me a long time to go over it. So just to make things easier, make sure you include your name and your class period so that I'm not looking through all of them. So at some point, I'll probably remember what class everybody is in. I think I remember most people's class period. But for now, just to keep things going easy, anytime you are sending an email, make sure you include your name and the class period, probably after the message or maybe before the message, depending on how long it is. But some people have pretty good emails, you know, like the email kind of has parts of their name in there, like B. Begay for Bob Begay. So a lot of times I can make sense out of it. And checking in also. So I know that we are taking attendance through check-in. Phone is probably the worst one. So if you're going to try to check in by phone, understand that sometimes I'm going to be right in the middle of something and I won't be able to get to the phone. But I think for checking in through email, I think morning is the best time to do that. Once the day gets started, it kind of gets really busy, and I'd rather get all of my emails done, you know, before the morning, and then at the end of the day, I have to start getting ready for the next day. And as it is right now, I don't have, or I don't think any of the teachers have a prep hour. So we don't have time that we can really set aside for checking attendance and anything. So I'm gonna say the best time to do the attendance is in the morning, probably before 8 o'clock. And I'm gonna probably check it again during lunch break, so 11 o'clock. So try to have them in before 11, but if you can, try to turn them in before 8. Anyway, let me go ahead and show you my YouTube channel. Where is, oops, it's not working. Huh, should, oh, well, okay, it's this one here. So there are the videos. I have Monday's lesson in 3 parts. And then I posted this one yesterday, both of these ones here. So 8:20 was yesterday, 8:19 was the day before. So they're all on there. So if you need to, you can go back and pause, rewind, play the videos over again. Some of them are from classes, which I think are a little bit, I think they're a little bit better because they include more information than just plain old the lesson. But I guess we'll see how that goes. We'll get some feedback, see how things go. And meanwhile, let's go ahead and get to the lesson today. So for the lesson today, we are going to be using this in your packet. This will be the work that you're going to have to be doing for today. And that is simplifying radicals. Actually, this was yesterday's assignment. Let me go ahead and grab today's assignment. So that was the one we did yesterday. The one we are doing today is going to be this one. What? Oh, sorry. It's the right page, wrong side. So again, I did print these back to back to save a little bit of paper. But anyway, here, this is the one we're going to be doing today. All right, so let's go ahead and get into it with our usual way. Let's do a little bit of yesterday. So I think this is where we left off yesterday. Some of these are going to be pretty easy. So let's go ahead and do this. If you don't see a number on the index, remember that the index is going to be 2 because square root is the smallest root you can take out. There's no such thing as a 1 root. So now we need numbers in pairs. So I'm going to go ahead and do this problem the long way. Just again, as a review, or maybe you missed it and this will be the first time you're seeing this. So I'm going to break down 25 into the factors of 5 times 5. And this allows me to see what number I'm taking out. W, 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 W. So I got 4 W's because it's W to the 4. And don't forget, these are all being multiplied to each other. Then I'm going to go through and I'm going to underline the pairs. You could circle them, whatever. But I'm going to underline them to show that I have a pair of 5s and 2 pairs of W's. So since everything is underlined, I'm going to be able to take everything out of the radical. So when it comes out of the radical, there's only going to be one of them because, again, don't forget what this means. If something is square rooted, that means it's a half power. So if I have 2 halves of a 5, then it comes out as a whole 5. Take the 5 out. And I have 2 W's, so I'm going to write it as W squared. And there we go, we're done with that one. So that was the long method. Short method, or the shortcut, is going to be kind of dividing. So with regular numbers, you're still going to have to find the cube root. So cube root of 8. So again, just use a factor tree, break these numbers down into numbers that you can get 3 of. So 8 is a cube number. And it's 2 times 2 times 2. So I have 3 sets, or sorry, a set of 3 2's. So I'm able to take those out from the radical. So they all make it out. Sometimes you will get numbers that stay in there, that get left in there, but not for this one. And then check our powers on the variable. So here I have 6 and 9, and both of those numbers are divisible by 3. So since they're divisible by 3, Let's go ahead and divide them. So 6 divided by 3 is 2. And n is divisible by, so 9, sorry, the n to the 9. 9 is divisible by 3, so let's go ahead and take that number and divide it. So 9 divided by 3 is 3, so there we go. Everything made it out. I have nothing left in the radical, so the radical is gone. We don't need it anymore. Okay. And I want to do some of these where we will have some of them left in there, because I think that might have been a bit of a confusing thing from yesterday. I can imagine that being a bit confusing. All right, moving on to the next one. All right, so for this first one, we have the 5th root of a number. So we're taking groups of 5. So how many groups of 5 can we make? So with 32, let's start by using the prime factorization. 2 and 16. 16 can be made with 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I'm able to take 32 and factor it down into 2. 2 times 2 times 2 times 2 times 2 is, well, it is a 5th root number. I'm not sure if there's a name for that. But yeah, we have 5 of them, so we can take the 5th root of 32. It's going to be 2. Now, if we check the powers of our variables, 10 and 15, so they're both divisible by 5. So that means I won't have any remainders left in the radicals. So r to the 10. So 10 divided by 5. So if you imagine that I have 10 r's, right, and I'm looking at groups of 5, that's 2 whole groups. And s to the 15, so 15 divided by 5, that's going to be 3. And I don't have 15 fingers to show you. But again, we just divide it. 15 divided by 5 is going to be 3. So that's how many groups of 5 we are able to get out of there. And again, I have nothing left in the radicals, so that's it for that one. We're done. Okay. Now let's go ahead and work on this one. So I have this 64, so cube root of 64. So I need a set of 3 numbers to get 64. Now sometimes people can break these numbers down even further. So like in this case, I broke it down all the way down to 2. But remember, whenever you have a cube root or some number like that, you want to get 3 of them. So I need 3 numbers that I can multiply to get 64. So 3 and 16. Oh wait, that's not going to work. 4 and 16. Sixteen is 4 and 4. Now you could break this down even further, and some people might do something like that. And that still kind of works, but whenever you take them out, you're still going to have to remember that they're all being multiplied to each other. And you would still get the same answer, but you would need to do it a little bit differently. So to keep things simple, just look for numbers that you can get 3 of. So even though I can break it down even further, we don't need to go any further than this, because now we have a set of 3 4s. So since we have 3 of them, we can get them all out of the radical. So we get 4 here, because that's the cube root of 64. And again, y to the 6. So divide that. 6 can be divided by 3 nicely. So I won't have anything left in the radical. I won't have any remainders. 6 divided by 3 is going to be 2. And it looks like we're done. There's not really anything else we can do with that one. But those ones were kind of on the easy side. We don't have any remainders or anything like that. So let's try to do some that are a little bit more difficult. So I'm going to skip this next slide and move over to some of the ones where we will have to make a bigger effort on some of these. And again, I'm trying to pick ones that will match the exercises on the homework a little bit better. All right, so yesterday we ran into a problem that was similar to 15 here. Now I think these problems may be a little bit more common. I didn't really look through all of the homework, but seeing that we're seeing it again, I think we are gonna have some problems with this one here. So yesterday I said something like, already simplified because you can't take anything out. But that's not entirely true because there are more things we can do to simplify it. And upon thinking about it some more, I realized, wait a minute, they have everything they need to simplify this problem entirely. Yeah, they have everything they need. They can do it. So what we're going to have to do is we're going to take this radical and use rational exponents. So we're going to convert it to rational exponents. And sometimes that's useful because, well, I'll show you in just a minute. So let's go ahead and convert it. So the inside number becomes our base. So our base is Q. Now we're going to have a fraction bar because we're going to use rational exponents. Bottom number is 8 and top number is 2. And just like I keep telling you, check your, if you have an exponent that's a fraction or anything that's a fraction really, anytime you have a fraction, see if you can simplify it. And there are two ways you can do that. You can either reduce it or you can divide it. In this case here, 2 cannot be divided by 8. So I'm going to end up reducing them. So to reduce them, again, you just look at the numbers, 2 and 8, they're both even numbers. Since they are both even numbers, I should be able to divide them both by 2. So 2 divided by 2 is 1, and 8 divided by 2 is 4. And just to kind of rehash one of those things, sometimes we change numbers. And when we change numbers, we don't necessarily change the meaning of them, because I know that's what you're used to. Since kindergarten, every time you add or subtract or do something, you are indeed changing the numbers. So let's go ahead and take 2 divided by 8. 2 divided by 8 is 0.25. All right, so 0.25, let's see if we get the same thing if we divide 1 by 4. It's the same thing, 0.25, so it's the same thing. Don't worry about it, because again, you're not changing the number. I know that's something that people have a tendency to do, but it's sort of like how in maybe in a family, you might have the same person known by different nicknames by different people. It's the same person, it's just a different name, that's it. So now that we reduced the exponent, I'm going to put it back into radical form, which I don't know if we need to, but since all the other answers and all the other questions were in radical form, so anytime we had a radical, we left it in radical form. So just for the sake of consistency, to just keep doing the same thing, I'm going to go ahead and put the answer of this one in radical form. So again, base goes into the radical. 4 is my index. And 1, okay, we could put q to the 1 power, but we don't need to because that doesn't tell us anything extra. And again, if it's asking you to simplify it, put it in simplest form so we don't need extra stuff going on. Remember, I told you that if you simplify something, and if you have any operations, anything add, subtract, multiply, divide, root, cube root, powers, always take care of those things. Try to have as few of those things as possible. So there you go. That is the simplest form of that problem. Okay, now here's one of the other problems I kind of wanted to focus on. So yesterday I did the finger method. We also did the write out method where we wrote out all of the factors and underlined them. But I'm going to show you a little bit of a different thing, because as we finished those lessons, I kept thinking to myself, you know, there's probably a better way that we can do this. So I'm going to show you a better way in the sense that it uses more of what you already know. So, right, so it's intuitive. It kind of follows what you already believe. So let's go ahead and work on that. So with this one here, we need to get our index, which is 2. So don't forget, if you see a radical without an index, it's going to be 2. So I'm going to show you this easier way now. And that is going to be, let's just divide it. All right. So probably in maybe 4th grade, you learned how to use this thing. Now I'm only working with the powers. That's it. The exponents are the only thing I'm working with. So like with any of these other ones we did earlier, all you're doing is dividing them. But again, in this case here, we're gonna have to pay attention to the remainder because 7 does not divide by 2 nicely. So how many times does 2 go into 7? 3 times, right? So it goes in there 3 times and we don't get a nice number. So if we're counting by 2s, 6 is the closest number we can get to, or we just multiply this in 3 times 2 to get 6.
Mrs. Dolores, hide into the office, please. Mrs. Dolores, hide into the office, please.
Now,
Staff, if anybody has any free time, we need help with the packets, please. Thank you very much.
all right. I guess you would deal with that on a normal school day anyway. All right, so we're finished with this. We have a remainder of 1, so we can't really do anything else with that. So I have 3 that can come out, right? So they're x to the 3. We're able to get those out. Now we're going to look at the y here. So y, and how many groups can I get? Now this one easily and nicely divides. 4 divided by 2 is 2. So we're able to get 2 groups out of that. Times, and again, we're going to put this times symbol like that here. And remember, we had 1 x left over. So that x stays in the radical. That's the one that got left behind. That's the one that it wasn't powerful enough to get out. And that's it. So I'm going to use this division method. I think it's a little bit easier than counting on your fingers, and it's definitely faster than writing all of them out, especially when you have something like y to the 16 or another exponent that's really, really large. Okay, so we're done with this page. Moving on to this page here. So I think this will be the last one we're going to do for this one, because after that it's a different exercise. All right, give you a minute or 2 to copy it, or maybe, yeah. Usually you'll have enough time. Oh yeah, and if you missed the announcements earlier, I was talking about posting the YouTube videos yesterday. So I went home and...
If you have your packets completed, please bring those down to the front office. Again, if you have your packets completed, please bring those down to the front office. Thank you.
I had my packet on Wednesday.
If you have them already in the front office, in the front area, then please disregard this message. Thank you.
All right, I had mine on Wednesday, so I'm not worried about that at all. Gosh, I wish there was a way I could pause that, because there's, you know, I'm gonna be posting this online, and it's always gonna be there now. So
Mr.
let's
Ness,
go ahead. What's that?
when are these packets due?
Well, I have some students turning them in now, and the new ones are available. Like I said, mine were available Wednesday, so if somebody was in here yesterday to turn them in, then they would be able to pick them up by now.
Oh, okay.
So, like I said, Monday is probably the best day to get them because by Monday, definitely everybody's going to have it. Like the announcements just said, some teachers don't have their packets already put together. So if you came in yesterday or even today, some of them might not have it ready, but definitely by Monday, everyone's going to have it done and ready. But if I have it today, I'm not sure how we're even going to do grades this time. Because I heard that we were going to do Schoology, and then I heard that we were going to do something else, and I don't know if we're still using the old Power School grade book or whatever. It's still stuff that we need to sort out. Anyway, let's go ahead and get to this last one here. Oh yeah, back to what I was saying before we were interrupted is that the YouTube videos are up. So I sent everybody a link yesterday, so you should be able to view those YouTube videos. And in fact, I think this one's going to be the YouTube video for the next one. And I'll kind of show you a little bit of that after this. Let's go ahead and get this done with really quickly. So fourth root of 16. So 4 numbers that multiply to 16. Now this one should be easy because there's only, a couple numbers that you can use. So that's 2 times 2 times 2 times 2. So that's 4 of them. And x is 12 divided by 4. 12 divided by 4 is 3. So there we go. All right, I just sort of ran through that one. Let's do this next one here because again, now this one is the one that we are going to have some remainders in. This is the one that's going to be a little bit trickier. So I have 27 and I need to take the cube root of 27, which is going to be 3. And 6 can be divided by 3 nicely. Oh wait, I don't need the radical in this case. So 3 and x square y. Now here's where we have a problem because 10 cannot be divided by 3 nicely. So you can just use your standard division. So 10 divided by 3, which is going to be 3. And the closest number we can get to 10 without going over is going to be 9. 9. And then we see how much we have left over. So 10 minus 9 is going to be 1. So we have 1 left over. So 3 sets got out. And 1 is going to stay in there. So we got to remember which one we're using, which is y. And again, I like to put a little dot right there just to show that they are 2 separate things. And that way the 3 on the y doesn't get confused with an index. All right, so I think some of you guys showed up a little bit later. So I'm going to go ahead and show you the YouTube channel. It's pretty snappy if I do say so myself. All right, so we're done with this. I'm going to move over to there, where is it? All right, now it's not showing up on my screen share. All right, there it is. I had to close out the calculator. So again, if you missed it, we're doing this one today. So if you looked at yesterday's assignment, it's going to be on the back side of yesterday's assignment. So this is the one we're working on today. Hopefully we'll get through this, assuming there aren't too many more interruptions. Now, I'm going to show you my YouTube channel. So it looks like this. It's even got my picture there. I need a new picture. I quickly took that one as fast as I could because we were doing Zoom meetings and I didn't want to have my front camera on. So there is my picture, and the channel is called Algebra 2, and I posted all of the videos that we've had throughout the week. So I have yesterday's, today's, and Tuesday, which was the first lesson we had was on Tuesday because Monday we didn't have a lesson. And let me just play one of these really quickly. So this is the one from yesterday. I hope this is a pretty good one to show. This way you kind of know what to expect. All right, so first thing, oops. Well, the thing I wanted to show with this one is that if you look at the screen from the videos, it doesn't record any of your it doesn't record anything like your camera or whatever. So if you were turning on your camera and you were in your pajamas and your cat jumps on your head or something, it's not going to record that. So if anytime you have your camera on, it just shows this figure here, this plain old avatar here. So don't worry about it. You're not going to show up on camera. It does a little bit to protect your identity enough to where, you know, I'm not posting people's faces or houses or something in the background. So don't worry about it. And again, I think the chat is entirely invisible as well. So nobody can see the chat or anything else like that. So when going over videos like this, I think it's better to not have the chat, or sorry, to do it with the chat and not through voice. I don't know, it depends. But like, some people have pretty good questions, and it's probably best that I answer those questions in there, in the video, so that way you're not, you know, that way, because there's probably plenty of other people that will also have that question as well. Anyway, let's go ahead and get to the other part. So anyway, here's the lesson for today. And again, I think so far it's been pretty good splitting the lesson, because if you miss a lesson or you come in late, you know, you're not missing the whole thing. And if you missed an entire lesson, you know, you're not missing an entire lesson. You're only missing about half of it. And I think so far that's been pretty good, because when I have questions, they usually seem to get answered pretty well. Because I'll get people at the beginning who say, I have a question about the homework, or, you know, I got stuck on a certain problem, then we'll go over it again. And I think that once they try, they kind of know what they're looking for, and they get their question answered, so they're able to complete the work without having to ask any questions. So I think so far this is a pretty good system. I'm gonna kind of stick with it until I know it doesn't work anymore. All right, so here's what we're gonna do today. We're gonna combine radicals using addition or subtraction. We're gonna learn the rules of working with radical expressions, combining radical expressions, and we're gonna learn to change and simplify radicals. So those are the objectives. All right, so like radicals can be added or subtracted in the same way of like terms. So I'm gonna pause right there and kind of go over an example. So here I have 3a plus 5a. So 3a plus 5a, if I asked anybody that without missing a beat, I'm sure everybody would say, oh, that's easy. It would be 8a. Because we've been adding terms with variables for a long time, you know, at least since maybe 8th grade, 7th grade, something like that. You're used to terms with coefficients and variables. The same is true with radicals. If two radicals have the same index and the same radicand, that means number inside the radical, then we call them like radicals. So let me go ahead and make an example now. I'm going to do the same sort of problem here. In fact, I'm going to even keep the same things: 3, 5, and 8. So it's the same kind of problem. And just to show you that it's the same, I'm going to replace a with root 2, just because it's the simplest root I could think of. And it's still going to be true, still true. 3 plus 5 is still 8. So in a way, you treat them just like they were variables. But you got to make sure that they, again, have the same radicand. They are like terms. They have to have the same index. So if, like, say, for instance, I have 5 root 2 plus 7 root 3. In that case, there's nothing I can do. They are not like terms. I can't put them together. So I'm going to have to find something else to do. Or even if I have two things that are the same radical, like let's say 3 root 2 plus 2 cube root of 4. All right, so these two are at the bottom are going to be not like terms. But sometimes there are things you can do to make them like terms. And that's what this one talks about here, this paragraph. If a sum or difference involves terms that are not like radicals, you may still be able to combine them after simplifying the radicals like we did earlier. So from from Tuesday, Wednesday, and yesterday, you can use those same things that we've been doing. In fact, it's probably best if we just go over them. So let's go ahead and get to some problems, and it'll probably start making more sense once you see how it works. All right, so let's go ahead and start with problem number 1. I'll give you like a little bit of time to write these down. Oh boy, we finally made it to the end of the week. So happy it's Friday. It doesn't quite feel like Friday though. I don't know. But it is Friday, weekend's tomorrow. And the first week did have a few hiccups, but I think it'll get better as, like I said, it'll get better as time goes on, as we start getting used to things, as the habit starts forming on how we do things. It'll go by much more smoothly. But anyway, I'm glad you're all here. Thank you for being here. You know, it makes it a little bit better. It just makes it better when you're here. Anyway, let's go ahead and get started. So here, we got to check to see if we have like terms. So root 3, root 3, root 3. So they're all root 3. So we're off to a great start. They are all like radicals, like terms. Now, if they are all like terms, just work with the numbers you have. 5 minus 2. 5 minus 2 is 3. There we go. And we don't need to change anything in here, so we don't change it. Just like if you're adding, like in the previous slide, I added 3a and 5a. You don't get 8a squared, you still get the same a. So you don't need to change the radical or anything. But we still have this root 3 here. So what is 3 root 3 plus root 3? All right, so if you were thinking 4 root 3, then you were right. And sometimes when I do this, I get students that are like, what? Where did 4 come from? There's nothing there. If there's nothing there, then it should stay the same. All right, again, don't forget, it still follows the same rules of adding variables. There you go. So here I have 2 terms that are like the same thing. And if I have 3a plus a, that would be 4a. And the reason why, if you remember, is because anytime you have a variable by itself, the coefficient, the number in front, is 1. So there is a 1 right here, okay? So it's just like love, all right? You don't see it, but it's there. Anyway, so we're done with that one. All right, that one wasn't too bad. Let's go ahead and do this one here, number 2. Now, if it helps, you can put a 1 there, because again, I don't have anything in front of this, so we would assume that it's going to be 1. Check for like radicals. So in this case, I have root 7 and also root 7. So they are like radicals, which means we can add them together. So 9 minus 1. This one's a pretty easy one. As long as you know that little trick of putting a 1 in front of numbers that don't have anything. All right, it's not 0 because 0 times anything would be nothing. And if it was 0, then it would just be 0. We wouldn't have anything. So sometimes I get people that say if there's nothing in front of these numbers, then it's 0. But no, because if it exists, if there's at least one thing, then it exists. Like if there was one unicorn, then that means you have one unicorn, right? That means they exist. There we go. So we're done with that one. Okay, not too bad. Those are pretty easy. Let's go on to these ones here. Okay, they're not the same. One is 2 and the other is 18. But remember, if you when we were on that last slide, it says sometimes you can do a little bit of work to make sure that they are going to be the same thing. So with root 2, okay, there's nothing I can do. All right, 2 is already the smallest number you can get by factoring. So let's try to get 18 and factor that down into something useful. So similar to what we've been doing all week, let's go ahead and try to get square numbers, which 9 is a square number. So we're going to take the square root of 9. Now you could also keep going and you get 3. And remember, if you have 2 of something, then they come out as 1. So in this case here, I have 3, or we can take the square root of 9, whichever one's easier for you to do. And it comes out of the radical. But 2 is still there. So it stays in there. So just like we did with the remainders when we were simplifying these, sometimes we have things that stay in there. We can't take them out. They're stuck in there now. But that's not entirely a bad thing, because if we look at the radicals, they are like radicals now. So they are like terms. We can go ahead and add them together. So root 2 plus 3 root 2. And again, by now, hopefully you know the trick. So if you just see a plain old root 2, there's a 1 in front of it. So 1 plus 3 is 4. So answer is 4 root 2. All right, so hopefully you can kind of see where that came from. So you have to simplify some of these radicals before you can combine them. All right, stretch a little bit. 27, and now if I look at this one here, there is a little bit of a clue. I know that there's probably going to be a root 3. Now, the homework is designed so that you use these ideas, these principles that you learn. So they're not going to be like bad all the time, right? There probably will be some things you can't really work with or something like that. But for the most part, they're going to follow the rules that you go over in the lesson. So anyway, here I have 27, and I use the prime factorization, so 3 times 3 times 3. But again, we're looking for square roots. So it means we're looking for pairs of numbers to take out. So I have a pair of 3s that we can take out. Or again, you can just go till you find a square number like 9. But sometimes you might need to take out more numbers. So that's kind of why I'm showing you this method here. Now again, since we have a pair of 3s and they come out, it's going to be one pair of, or one 3. This one here gets left behind because it has no buddy to come out with. So it stays in there. It just stays in the radical because it's a remainder. It's left over. But again, at least now we have like terms, and like terms, root 3, we just add, or in this case, subtract the coefficients. 5 minus 3 is 2. And again, root 3 stays the same. We don't need to do any work with that because we're not multiplying. And there we go. Okay. Not too shabby. All right, moving on to the next one. If you're taking notes, I'll give you a little bit of time to copy these down. Oh man, I woke up with one of my noses is really stuffy this morning. I don't know, I feel a bit slow today also. I don't know, maybe it was all that rain that happened yesterday. That was a crazy day yesterday. I got house pets. So I leave the windows open so it doesn't get too hot during the day, because like all week this week we've had over 100-degree weather. So I usually leave the windows open so that they can get a little bit of air circulation and they're not so hot. But yesterday, right around a little bit after 3, right about the time to go home, the wind picked up and I got dust everywhere in my house, and then it started raining and I had to like run home and close all the windows as soon as I could. I don't know. But anyway, with all that rain and dust yesterday, that's probably why my nose is stuffy. Anyway, let's go ahead and get to this. So now I have exercise number 5, and there are 2 numbers that I have with the root, and I got 98 and 2. So those are very different numbers. Now I can't simplify 2, but we can try to simplify 95. So let's try to do that right now. I'm going to try to take 95 and take the factor of it. Now, I probably should have thought of this before I just started, because sometimes if you think ahead, you can make it easy on yourself. But I think I just got lucky, because 98 divided by 2 is 49. And as you may remember, 49 is a square number. So being a square number, we can take the square root of it. So we'll go ahead and take the square root of 49, which is going to be 7. And I have 2 left over, so 2 is still in there. But again, there's a little bit of a clue that if one of them is 2, then the other one has a pretty good chance of also being 2. Now again, be careful, because I think some of these may not be simplifiable. You may not be able to simplify them the same way. But in this case, it works out pretty well. Now I have some numbers with, I have terms with like radicals. So that means they are like terms. So 7 minus 3, let's go ahead and subtract that. And we have 4 times root 2. There we go. Now let's move on to number 7. Now this one here is a bit of a weird one, because I have 72 and 50. I might have to change both of these. Now sometimes you can get away with changing one, like we did on the last one, but sometimes you have to change both of them. And in this case, it looks like we're going to have to do that. Now, 72 has a lot of factors. You know, you can go 1 times 72, 2 times 36, 3 times 24, 4 times 18 or something like that. There's a lot of numbers we could use. So I think it might be easier to start with 50. So again, a little bit of planning ahead can save you some work. So let's go ahead and take 50 apart, because I think that one has fewer factors and fewer numbers that you can make mistakes with. So let's go ahead and break it down. So 50 is an even number, so I should be able to divide it by 2, which is 2 times 25. And there we go, square number. So now I know that 50 is going to be, let's take the square root of 25. So square root of 25 is 5, and 2 stays in there. Now this is a pretty big clue, because I know that there's a good chance that we can get 2 from 72. So I'm going to go ahead and try to factor out 72. And again, if I ask someone to multiply two numbers to get 72, chances are pretty good they're gonna say 8 times 9. Because that seems to be what people usually do, and they kind of pick numbers with factors closer to each other, like 8 and 9, rather than say something like 2 and 36. But again, the clue from the other one we had is that it's going to be 2, right? Because we got to get root 2, so this means that there's a good chance that 2 is going to be left over. And if I chose 8 and 9, well, 9 is a square number, but we're probably going to have something different. So I'm going to show you the right way, and I'm going to show you kind of another way that's sort of wrong, but you can still get the right answer from it. But anyway, still working on the problem. 2 and 36 make 72, and 36 is a square number, so that means that we are going to get 6 as our outside number. They are like terms, so we can go ahead and put them together, combine them. So we have 11 root 2. And like I said, you can save yourself a little bit of work by thinking ahead. What would happen if we weren't thinking ahead and we just went with 8 and 9? Well, if you were going with 8 and 9 and you were like, oh wait, 9 is a square number, so we should be able to take the root of it. So you'd have 3 root 8. And that's not very helpful to us. But like I said, you can get the right answer by factoring it again, because in this case, 4 is also a square number. So if I take numbers out, so in this case, I'm going to take the square root of 9, and I'm going to take the square root of 4. So square root of 4 is 2. I would still get the same thing. See how I have 3 times 2 because I took out square root of 3 and square root of 2. I'm still going to get 6 root 2. But I did have to do a little bit of work. And that's what I mean by, again, if you think ahead, you can save yourself a little bit of work. All right, you need a guy pointing at his head meme right here. Oh yeah, maybe I should do the meme of the day again. Maybe I'll do it right at the beginning of class. That way the people here on time will be the ones to see it. I think I've already gotten a couple of them sent in. Okay, now time for some of these really confusing ones because I have 3 terms, right? 1, 2, 3 terms. So I got 3 things going on and they're all different. So I'm gonna have to do a lot of simplifying on these ones, it looks like. And with my last class, I only finished these 2 and then, that was the time. One other good thing about trying to keep the videos about an hour is YouTube usually has a time limit and you have to like do other things for your account to get higher time limits. So I'm trying to keep my account basic. Plus that they upload a lot faster if they're under an hour. So let's try to finish these 2 and then we'll be done. Okay, so I have 50, which we just did. We just have the root of 50 right here. See, from the last problem, we already did it. So let's go ahead and I'm gonna do that now. Be careful because there's gonna be some things that are gonna be like, where did that come from? So we got to do a little bit of work to keep track of what's going on. So square root of 50, we know that's going to be 5 root 2. 5 root 2. And again, these are multiplying to each other. Now that takes care of the root 50, but this root 2 is still there. We didn't do anything to get rid of it. So we're going to have to just sort of tack it on in the front. So again, the 2 is already there, and once I simplify root 50, it becomes 5 root 2. Now, let's simplify all the radicals before we start working on the rest of this. So now I have 18. So let's go ahead and simplify 18. And again, we need numbers that we can multiply to 18, which I think 6 and 3 are going to be the first thing most people will say. But again, we're looking for square numbers, so 2 and 9. And again, there's a bit of a clue that if you have a root 2, that you might be looking for other root 2s. Now, some of these are going to be like root 3s or different roots. I think with all of these so far, they've been root 2, but they can be root other things like root 2, root 3, root 5, root 7, different things. So anyway, let's take the square root of 9. Now, okay, here's another tricky thing, because in my middle term right here, my problem has a 3. Now this 3 is from here, it's from the problem. But I'm gonna get a second 3 from the 9, right? Because we're gonna take the square root of 9 times 3. Because we took the square root of 9, that's where this 3 came from. And 2 is still there. Like I said, there's a bit of a clue there because 2 is likely going to stay there. And now I'm gonna have to do this last term here. So, oh boy, I have a lot of stuff going on here. All right, 32. So I'm gonna take the factor of 32. Now again, there is a clue that I'm trying to get 2. So if I factor out 2, I get 16. And 16 is a square number. We can take the square root of 16. So it's underneath the radical, which means I got to take the square root of it. 16 is 4 times 4. And 2, again, is still in there. So we end up with 4 root 2. All right, so there we go. We simplified all of the radicals. And we can see that we do have like terms now. So let's go ahead and clean this up a bit by multiplying these here. So follow your order of operations. So like, okay, so actually this is a good point for me to talk about this because I've actually never really mentioned this, but it just sort of hit me just now. And that is order of operations. We're all familiar with the PEMDAS, P-E-M-D-A-S. We know to do parentheses first, but where do roots fit in on this? And if you remember, it's parentheses, exponents, and multiplication. Now, exponents are on the same step as roots, because don't forget, these are inverse operations. Being inverse operations means that they are the same step. So whenever you would take care of an exponent, you also take care of your radicals or your roots also at the same time. But we don't say, you know, PEMDAS is P-E-R, PEMDAS. No, that doesn't work out. So again, it fits under exponents. So 10, make that 10 a little bit better. So multiply these together. 10 root 2 plus 9, because 3 times 3 is 9. 2 minus 4 root 2. All right, so I didn't need to change anything on that last one. So let's go ahead and start adding up the coefficients. 10 plus 9 is 19. And 19 minus 4 is 15. And again, the root doesn't really change. Still the same thing. And there we go. I'm gonna erase some of these so that I have a little bit more space to write with. I guess I could have wrote over here, but oh well. All right, so let's go ahead and work on this last one. Then we'll call it a day. Or I guess for today, we'll call it a week. All right, so 27 is 3 and 9. Now again, this is kind of a clue because I have 3 and a root number. So now that I have a root number, and it might be easier to go through and do the easiest one. Like if I was planning ahead, I might do this middle one first. But in this case, your 27 is also pretty easy to factor, so it wouldn't make a difference. Now again, there is a 3 on the outside of this problem. So that 3, the first 3 is from the problem. The second 3 is because I took the square root of 9. And this 3 is the remainder, right? Because I can't take the root of that number, or it has no partner to get out of the radical with, so it stays in there. So there I end up with 2 on the outside. I end up with a 3 and another 3, but again, they're from different places. So sometimes that can be a little bit confusing when you see numbers just sort of coming out of nowhere. Now let's go ahead and do 7, which again, there is a clue. I know this first radical is 3, so I can try to factor it out with a 3, and I should be able to get the other number out of there. So in this case here, I have 4, which 4 is a square number. Now again, here's another confusing term. So this 4 is from the problem, but we're going to square root this 4. Square root of 4 is 2, so that this 2 comes out. And this 3 is still underneath the radical, so it stays there. Minus root 300. Now, root 300 is going to be a confusing one because there's a lot of factors that you can take out of 300 because it's a pretty big number. It's even and it's divisible by a bunch of other numbers too. So like 1 times 300, 2 times 150, 3 times 100, 4 times, you know, I can divide 300 by 4. I don't know what it is right off the top of my head. I can divide it by 25, I can divide it by 50, we can divide it by all sorts of numbers, 60 even. But again, there's that clue. If I'm going to factor 300, I want the radical to be 3 because I want it to match my other 2. So there you go, a little bit of planning ahead. I can see that 10 is a square number. So I'm going to take the square root of 100 and that becomes 10. 10 root 3. So again, there we go. We saved a lot of work. Otherwise, we'd be trying to go and find a bunch of different factors and then putting them all back together once we take them out. Again, it'll still give you the right answer, but you want to make things easy on yourself because you deserve it. All right, now I'm going to multiply these together. 3 times 3 is 9. 4 times 2 is 8. And 10 root 3. There we go. Now they're all ready to be combined. So let's just go from left to right. 9 plus 8 is 17. 17 minus 10 would be 7. 7 root 3. And there we go. So that looks like that's it for the lesson. And it looks like we're pretty much done for today. Let me go ahead and go back to the main screen. Where are we? Oh, I always forget how to do this part here. All right, so there we go. That's it for today. If you have any other questions, I'll be around for a bit. Make sure you have all your questions answered. If not, you can always get through me by email or whatever. Until next time, I'll see you later. Enjoy your weekend.